Hello everyone, my name is Alok Kohli. I am a BTech third year engineering physics student from IIT Roorkee, and today I am going to give a presentation on the topic proximity sensors, which is under the course PHN 310. So here we go. So here is a brief overview of what we are going to discuss in the PPT. So first of all we will discuss what are the proximity sensors, working principles, types of proximity sensor, applications and limitation, and then we will finally reach the conclusion. So what are proximity sensors? Proximity sensors are the devices that can detect the presence of an object in their vicinity without any physical contact. They use various physical properties such as electromagnetic fields, capacitances, sound waves, light or magnetic field to detect objects. They have very wide range of applications. They are widely used in industries such as manufacturing industries, automotive, aeros aerospace, and consumer electronics. We will now see the working principle of proximity sensors. So, all proximity sensors work on the principle of detecting changes in a physical property such as electromagnetic field, capacitance, sound waves, light, or magnetic field. So, what happens is that when an object enters the field of the sensor, then there is a change in the physical property which are mentioned above. So these properties are then detected by the sensor. The sensor then triggers an output signal which can be used to control a process or send an alert. Now, what are the types of proximity sensors? So there are mainly four types of proximity sensors: inductive proximity sensor, capacitive proximity sensor, ultrasonic proximity sensor, and photoelectric sensors. So we will discuss about them in detail in the next slides. Inductive proximity sensors. These are the most commonly used type of proximity sensors. They have a very wide range of applications. These proximity sensors are used to detect the metallic objects only. These sensors consist of a coil that generates an electromagnetic field. So, what happens is when a metallic object enters the field, it induces the eddy currents in the object, which causes the change in the electromagnetic field, as you can see in the figure. So, when there is a change in the electromagnetic field, then the voltage will vary. So, the sensor detects that change and triggers the output signal. The second type is capacitive proximity sensors. So these type of sensors are used to detect non-metallic objects such as plastics, paper and liquids, as these have lesser values of dielectric constant. So as you can see in the figure, this type of sensor consists of two parallel plates that forms a capacitor. So it this capacitor has its own electric field. So when an object enters the sensor's field, then the capacitance is changed. So this change in the capacitance changes the voltage value, and this voltage is detected by the sensor. Now, the third type is ultrasonic proximity sensors. So, ultrasonic proximity sensors use high frequency sound waves to detect the presence of objects in their sensing range. So, ultrasonic proximity sensor consists of a receiver and a transmitter. The transmitter is used to transmit the sound waves, and when an object comes in the field of the sensor, then it reflects back the sound wave and the receiver receives the signal. So this signal is detected by the sensor and hence triggers the output signal. So they are used in industrial applications where non-contact sensing is required, such as in automated assembly lines or robotics. Ultrasonic sensors can detect a wide range of objects, including transparent or translucent objects, liquids, and powders. So they are also useful in the application where other types of sensors such as optical or magnetic sensors may not be reliable due to factors such as dust or dirt. The last one is photoelectric proximity sensors. Photoelectric proximity sensors uses light to detect the presence of object in their sensing range. It emits a beam of light and detects when an object interrupts the beam. Photoelectric proximity sensors consist of a transmitter and a receiver. Transmitter is used to emit a beam of light, and when an object comes in the sensing range of the sensor, the it reflects back the light and the receiver receives it. Thus, this triggers the output signal. So, in this way, the photoelectric proximity sensors work. It can detect the object of various shapes and sizes. One of the limitations of the photoelectric proximity sensors is that it can't be used to detect the transparent objects, as the light will not be able to reflect through it and it will just pass through the object. So they have wide range of application in the conveyor systems and packaging machines. This is a diagram of photoelectric proximity sensor. So it consists of emitting element, which is the transmitter, and a light receiving element, which is the receiver. So this transmitter transmits the light, and when an object comes in the range, suppose this element comes in the range of the sensor, so then it reflects back the light and the receiver receives it. The circuit inside this changes and means receives the signal, and thus the output signal is triggered. This is how the photoelectric proximity sensor works. Now we will see the applications of proximity sensors. The first one is robotics and automation. Proximity sensors can be used to detect the presence or absence of objects in the robot's environment. This helps the robot to navigate and avoid collisions with obstacles. The second one is conveyor systems. Proximity sensors can be used to detect the presence or absence of objects on a conveyor belt. Most of the time, photoelectric proximity sensors are used for this purpose. Third one is automotive and aerospace industries. Proximity sensors are used to detect the position of landing gear during takeoff and landing. They are also used in the collision avoidance system to detect other aircraft and objects in the vicinity. Proximity sensors are used in packaging and labeling machines also. They can be used to detect the position of labels on the packaging materials, ensuring that the labels are accurately applied and aligned. We can also use them in the security systems. Proximity sensors are used to detect the presence of intruders in a security area, triggering alarms or alerts. They are also used in mobile devices and wearables. They are used to detect the presence of user's face or ear during a phone call, automatically turning off the display to save battery life and prevent accidental touches. We can see a lot of application of proximity sensor in our surroundings. Proximity sensors have certain limitations which we are going to discuss in this slide. The first one is limited range. Proximity sensors work by detecting objects within a certain distance range, and if an object is too far away, it may not be detected by the sensor. This can be a problem in certain applications where a longer range is required. The second one is interference. Proximity sensors can also be affected by the interference from other sensors or electromagnetic fields in the environment. This may disturb the working of proximity sensor. Limited sensing capabilities. Some proximity sensor may not be able to detect specific characteristics of objects such as their shape or texture. This can limit their usefulness in certain applications where these characteristics are important. For example, the photoelectric proximity sensor cannot detect the transparent objects. So this is also one of the limitations. So from the previous slides, we can conclude that proximity sensors have a very wide range of applications. These are an essential part of modern industries and consumer electronics. There are different types of proximity sensor that can detect various type of objects and operate under different conditions. For example, the inductive proximity sensor are used to detect the metallic objects. The capacitive proximity sensor are used to detect the non-metallic objects. So it depends on the type of proximity sensor that what kind of object we are detecting. So understanding the working principles and application of proximity sensor is very crucial for designing efficient and reliable systems. So this was all from my side. Thank you.